Let us start with session 1 of our course. So let us start session 1, Introduction to the Arduino. A brief history about Arduino. It was created in Italy in the year 2005. It was one of the first open source hardware. Initially it was based on the Atmel processor, and the coding is accessible by all and also transferable. Here you have come across a new term called open source hardware. Well, when the Arduino was created in the year 2005, till then there was no concept of open source hardware. You all might have an idea of what open source is. If you don't, let me explain. Open source is a concept where the design files or the programs of that particular system is available to the public and anyone can use it and develop upon it. Till the year 2005, the concept of open source software was there, where entire software architecture or a piece of code was made open source, wherein anyone could take that particular piece of code or that software and again develop further upon it. But when it came to hardware, when it came to the electronic boards, till then there was no open source board, and the board manufacturing was limited to the companies designing and producing them, and people had to follow the company's guidelines to use it. When the Arduino came into picture, a new concept called open source hardware was introduced to the world. What open source hardware meant was the entire design file of the Arduino, that is your schematic, circuit design, and PCB files, everything was made available to the public. Anyone could use those files and modify them if they wanted and create new sets of boards called Arduino compatible boards and start selling them. There was no restriction to the Arduino design board. So this is where your open source hardware came into picture, thus revolutionizing the world of DIY and prototyping. I mentioned here that the coding is accessible by all. Arduino is a complete open source community, and even the codes are open source and anyone can access them, and they are also transferable. The coding is basically mainly based on your C++ processing and Java. We'll look into this in the further slides. What exactly is the Arduino? The word Arduino can mean three things. It can be a physical piece of hardware, it can be a programming environment, and it can also be a community or philosophy. A physical piece of hardware is nothing but your Arduino development board. A programming environment is nothing but your Arduino's integrated development environment or your compiler and Arduino toolchain. And a community and philosophy is nothing but your Arduino open source community. So whenever you hear the word Arduino, it can mean one of these three things. But all in all, an Arduino is a combination of all these three things. The Arduino is not a microcontroller. Many of you will be having a misconception that an Arduino is a microcontroller, but it is not. When we talk about the Arduino hardware, we mean the Arduino development board, and the board houses a microcontroller. The board itself is not a microcontroller, but it houses a microcontroller. When we talk about the Arduino software, we mean the Arduino IDE or the Arduino program. What is a microcontroller? If Arduino is not a microcontroller, then what exactly is a microcontroller? Microcontroller is a small computer on a single chip. It generally contains a microprocessor, memory, and some input output ports. A microcontroller is typically embedded inside some device that they control, and they typically need a development board using which we can work on the microcontroller. You cannot directly work on a microcontroller, just the microcontroller chip, you cannot work with it, so it generally requires a development board using which we can work on it. This slide represents the components in a microcontroller. In the previous slide, I mentioned a microcontroller is a computer on a chip. So, like how a typical computer has a RAM, ROM, your uh, crystal oscillators, etc., and a hard disk where you store memory, etc. A microcontroller also has these things, but in a very miniature version. You can see that it will be having an oscillator, analog to digital converter, a microprocessor which is the main brain of the entire thing, a RAM for your temporary memory, a program memory for your permanent program to store your programs, and other components, a power supply circuit, everything. So a microcontroller generally consists of these and some more things. It depends on each microcontroller as well, the architecture. But in a very broad spectrum, a microcontroller will definitely have these basic things in them. We talked about the Arduino being a development board and not a microcontroller, and we saw what a microcontroller actually is. Then, what is a development board? Well, it is nothing but a printed circuit board designed to facilitate work with a particular type of microcontroller. So, depending on the microcontroller type, the development board is designed. But again, generally, the typical components in any development board includes the power circuit, programming interface, some basic inputs and indicators like your push buttons and LEDs, and I/O pins to extract the microcontroller pins. So these are the typical components of a development board. So what is an Arduino? An Arduino is the go-to gear for artists, hobbyists, students, and anyone with a gadgetry dream. Why was the Arduino created? During that time, there was a formidable challenge to the creators how to teach students to create electronics projects fast, simple, and efficiently. Till then, if anyone had to do a project in electronics, then they had to learn coding, they had to learn programming of that, they had to learn huge things related to the particular board that they'll be working with. So that was a challenge, how to make them learn in a very simple, very efficient manner and as fast as possible. That was how the Arduino was created. So let us now get started with the actual work. The hardware components required for this course is as follows. If you have purchased the kit, an Arduino kit from us, we would have couriered it to you and it will contain all of these components. If you haven't purchased the kit from us and you want to do it with your existing components, then you need the following. First and foremost is the Arduino board. You can use a Uno R3 board, or if you have purchased the kit from us, we would have given you the flip base board in the kit. Next, you'll be requiring a breadboard, a few LEDs, a USB cable, some jumper wires for making your circuit connections, a light dependent resistor or a light intensity sensor, a couple of 1 kilo ohm and 10 kilo ohm resistors, and a push button. So these are all the components required for you in this course to do a few experiments as well. So these are the software components you need to work with it. For programming, we'll be using the Arduino IDE, wherein you have to download from the link provided and install it. Apart from the IDE, you will also be requiring the Arduino drivers. The FTDI driver will be installed along with the Arduino IDE whenever you download and install it. But some of the boards come with a different driver IC called CH340. You can download that particular driver from the link provided and install it. Overview of the Arduino Uno development board. On the top left corner, you have the power circuit. The power circuit consists of your diodes, regulators, capacitors, etc. Over here is your programmer circuit, and this is the heart of the Arduino development board, the Atmega 328P 8-bit Atmel microcontroller. This is your DC power input jack. You can input 9 to 12 volts DC current, DC voltage, regulated voltage. This is the USB jack. You can connect the Arduino development board to your computer using this USB cable. You can also power up the board using the USB cable itself. There is no need to connect any external power. You can power the board using the USB cable itself. This is the reset button used to reset the microcontroller whenever you want. These are your digital I/O pins as well as analog output pins. You have digital I/O pins from 0 to 13, and some pins have dual functionality of being a digital I/O as well as a analog output pins. Those pins are your pin number 3, 5, 6, 9, 10 and 11. Over here is your analog input pins. These are your dedicated pins for analog input A0 to A5. So there are a total of 6 analog input pins. And these are your power pins wherein you can get 5 volts, 3.3 volts and ground. Looking at the Arduino board, instantly we can notice that there are dedicated pins for analog input and dedicated pins for analog output and some digital I/O pins. So why is there a difference of the pins? Well, you know that Arduino Uno development board has a microcontroller, and any microcontroller or any computer system can understand the logic, the language of your binary logic or your binary language of zeros and ones. But in nature, most of the signals are analog. They are of type analog, and many of your sensors that are also available are generally analog sensors. So in order to read those analog signals, the Arduino board or any microcontroller cannot understand the analog signals directly. They cannot read the analog signals directly. So in order to convert the analog signals to the digital equivalent signals, there is a chip or there is a IC called analog to digital converter. So what that converter does, it converts the analog signals into its digital equivalent. So on the analog input pins, each pin has a inbuilt analog to digital converter inside the microcontroller. So what it does is, whenever you input analog signals to these particular pins, the ADC takes care of converting those analog signals to its digital equivalent and then feed it to the microcontroller. The Arduino board has a 10-bit ADC. So the resolution of the analog to digital converter is 10 bits, meaning you can obtain 2 power 10 discrete values. So after the analog signals are converted to the digital equivalent form, there are possibilities of 2 power 10, that is 1024 discrete values. Similar to ADC, when you need to read analog input, if you want to write analog output, if you want to send analog signals out of the board, then you need to do a reverse operation. So some of these pins, the pins 3, 5, 6, 9, 10 and 11, have a digital to analog converter that does the reverse operation of the ADC. But the digital to analog converter in the Arduino board is 8-bit resolution. It has a resolution of 8-bit. So 2 power 8 is nothing but 256. It can give 256 discrete variables. Discrete values. Similar to the Arduino Uno baseboard, we'll look
into the flip baseboard as well. The flip baseboard also houses a Atmega 328B 8-bit microcontroller with a different form factor. That is this IC right over here. It also has a dedicated power circuit which gives dedicated power supply to the board if you input the power from external source. You have a dedicated power input jack. You can again input 9 to 12 volts regulated DC power to the board using the DC jack. It has a dedicated USB pin wherein you can connect the microcontroller to your computer using this USB jack. Also, you can power up the board from the USB jack itself. Over here you have the reset button. If you want to reset the microcontroller's operation, you can use that button to reset it. These are your dedicated power pins. You have 3 pins each of ground, 5 volts and 3.3 volts. Over here you have your analog input pins similar to your Arduino Uno, but these input pins are from A0 to A7. So there are a total of 8 analog input pins here. And over here you have your digital input output and analog output pins, again similar to the Arduino Uno board. The flip baseboard is Frugal Labs baseboard. It is based on the Arduino Nano board, and it has a Arduino Nano bootloader. So if you want to do any programming with the flip baseboard, then the board you need to select in your Arduino IDE, we'll discuss that in the future, is the Arduino Nano board. Okay, so you just need to understand that the flip baseboard is a 100% Arduino compatible board, and it is based on the Arduino Nano board.
We saw what a development board was. So what is a breadboard? It's a very funny name. Bread, you know, you would have had bread every day. But breadboard, what the hell is it? Well, a breadboard is a rectangular plastic board with a bunch of tiny holes in it. These holes let you easily insert electronic components to prototype an electronic circuit. So this is what a typical breadboard looks like, and it comes in different sizes, a full, half and a mini. If you have purchased the kit from us, we would have provided you with the half size breadboard. So you can see these holes, it somewhat represents a bread. It gives you a feeling of a slice of bread. That's why the name a breadboard. So what is in a breadboard? Well, the breadboards have metallic strips in them that facilitate the connection of your circuit. The layout of the breadboard is as follows. You have the power rails on the top and bottom. You can see that the rails are represented by plus and minus. These are just for indication, and you can use any power rail for anything. You can see that the power rails are horizontal, so all the holes on all the power rails, all the holes are connected to each other in a horizontal fashion. Similarly, on the middle of the breadboard you have a big space that differentiates the top and the bottom part, and in the middle of the breadboard all the holes are connected in a vertical nature. In the development board we saw that there are some input pins and some output pins. So what is input and what is output? This is referenced from the perspective of the microcontroller, and inputs are nothing but the signals or information that is going into the board, and output is nothing but any signal exiting the board. Almost all systems that use physical computing will have some form of output. Let us look at some examples. All your sensors fall under the category of input, and all your actuators fall under the category of output. So in the examples of input includes your button switches, push buttons, light sensor, flex sensor, humidity sensor, etc. And for output, examples like your LED, LCD displays, DC motor, your buzzers, relays, etc. Let us look at the concepts of analog and digital. I mentioned earlier microcontrollers are digital devices, and they understand your 0 1 binary logic, zeros and ones. Your Arduino or your flip baseboard is a 5 volts microcontroller based development board, and logic 0 represents 0 volts and logic 1 represents 5 volts. 0 and 1 is equivalent to your on and off function. The 0 and 1 are called discrete values because you have two discrete levels. You have a level 0 or level low and level 1 or level high. But in the case of analog signals, the range can be anything between low and high. So between 0 and 1, you have 0, 0 0.1, 0 0.2, 0 0.3 up till 1, 2, 3 up till 5 volts. So any analog signal can range between 0 and 5 volts. So this is your main difference between analog and digital. So let us now look into the Arduino program development. The Arduino programming is based on your C++ concepts without 80% of the instructions. So just combine all the concepts of your C and C++ into one and remove 80% of the instructions from it. What is remaining is most of your Arduino concept. It also has a handful of new commands, and in Arduino environment the programs are called sketches. When you write a C program or a C++ code, you call them as C programs, C++ programs. In Arduino, the whatever code you write, you call them as sketches. It is just a relative term. It is just a term used in the Arduino community, and it means the same. There's no difference. The sketches require two functions, and those are your setup function and your loop function, and the return types are void. These two functions are mandatory for your sketch to compile. The setup function runs first and only once. Whenever you power on your system, that is whenever you power on the microcontroller or whenever you reset the microcontroller, the first function to run is the setup function, and it runs only once. The loop function runs over and over until the power is lost or a new sketch is loaded. The loop function is equivalent to your while one loop in your C++, and it runs infinite number of times till the power is lost or it is replaced with a new sketch. This is the Arduino's Integrated Development Environment, or IDE for short. So what is an integrated development environment? It is a software that combines your uh, tool chain, the compilers, and a space to write your program and execute it. So in previous times, before Arduino came into picture, there was no standard development environment for a particular board. You had to develop a custom tool chain for it, you had to integrate the compilers to it, and you had to also integrate a different editor wherein you can type in your codes and save and everything. So when the Arduino came into picture, the creators combined everything into a single integrated development environment, and the back end of the IDE is your GCC compiler. On the front it has a text editor, and you can just write your programs here, save it, compile it, and burn it, everything using a single piece of software. The two required functions or methods or routines are shown here, and this particular code is called the bare minimum code. To upload any program to the Arduino, these two functions are mandatory, and that's why it is called the bare minimum code. The compiler, the main features of the compiler is there are numerous sample sketches that are already included, and they're located under the file examples option. Once the sketch is written, it is uploaded by clicking on the upload button or just pressing Ctrl U together. The compiler is very simple to use and it has all your development tools in it. Let us get into the Arduino C programming part and introduce ourselves to the Arduino C specific functions. So these are the most commonly used Arduino C functions in your Arduino coding. The first function is your pin mode function, and it takes two parameters, pin and mode. It designates the specified pin for input or output. So pin is an integer that you specify the pin number that you want to work with, and mode is nothing but input or output. So whether that pin is an input pin or whether it is an output pin, you specify that using this function. Next, you have your digital write function. Suppose you want to send logic 0 or logic 1 onto a particular pin, then you use this function digital write, and it takes in two parameters, the pin and the value. Pin again is the pin number on which you are trying to work with, and value is nothing but high or low. High is equivalent to logic 1 or 5 volts, low is equivalent to logic 0 or 0 volts. So what this function does, it sends a voltage level to the desired pin, to the designated pin. Similarly, if you want to read something from a pin, then you use the function digital read, and it uses only one parameter, that is the pin. So it reads the present voltage level from the designated pin whenever you call it. Similar to digital write and digital read, you have the analog versions as well, that is analog write and analog read. Analog read uses the designated analog input pins, and the range of the analog read function is 0 to 1023. Digital read has only two ranges or two discrete values, 0 and 1, but analog read ranges change from 0 to 1023. You also have a couple of serial commands like your print function, print ln function, write function. Print is nothing but similar to your printf function in your C++. Print ln is print with a new line. So it's like whatever you print using the print ln function, the string will be printed and the cursor will be sent to a new line. Writing is, suppose you want to write to a particular serial interface, then you use the write command. The programming syntax follows your C++ syntax. It is similar to your C++, and the formatting requirement is the same. You have the double forward slash for a single line comment, a forward slash followed by a star and ending with star, and a forward slash is for your multi-line comment. Your curly braces or your flower bracket is used to define a block of code, and your semicolon is used to define end of line of the code. The programming variables are also similar to your C. There are a few exceptions, but these are the most commonly used variables. You have your integer type that is of 2 bytes, you have your long, you have your boolean, float, character. So these are all similar to your C. You also have math operators used to manipulate the numbers. So these are your math operators, the equal to sign for assignment, the percentage sign for modulo, plus for addition, minus for subtraction, star for multiplication, and forward slash for division. The Arduino C language also supports compound operators as well as comparison operators. So these are your compound operators listed and your comparison operators listed. You also have control structures. These codes execute code based on conditions. So you define some conditions, and depending on them, another piece of code is executed. Again, similar to your C, you have your if structure, else if else, then you have your for loop, while loop. So all of them are, the working is exactly similar to your C. So when it comes to your Arduino programming, this is called the big six concepts. So whenever you're trying to write an Arduino sketch or an Arduino code, these six functions are the most commonly used functions, and hence named the big six concept. And they are nothing but your digital write, analog write, digital read, analog read, if statements and boolean statements, and serial communication. So these are categorized as the big six.